So this is the Unit 3 review key. I'm going to go through each one of these questions, explain how you do all these, so hopefully this helps you study for the test on Friday. All right, first thing we have up here is end behavior. We're going to look at how to find the end behavior given a function and not a graph. If you're given a function, there's two things you're looking at. One is the function positive or negative, and then two, what is the degree of our function? So we're looking at the highest exponent. So our function here is negative, and it's an odd degree. Okay, so what that means, it's an odd degree of one of two options. You can have a graph that looks like this, which is positive, or a graph that looks like this, which is negative. Ours is the second type because it's negative. So our graph is going to look like that. And what we're going to do for our end behaviors, we want to find, I'm going to make the graph a little bit bigger over here. We want to find, as the graph is going to the left on the x-axis, what is this doing? So as the graph approaches negative infinity, all right, going to the left, all right, what does f of x approach? All right, it goes up towards positive infinity. Let's do this. There we go. There we go. Okay. Sorry, I'm going to try and make the pen a little bit thinner. All right, the other part is, as the graph goes to the right towards positive infinity, what does f of x do? What's the graph doing? The graph is going down towards negative infinity. And this is the end behavior. Okay, what is the ends of the graph doing? How are they behaving as you move to the left and to the right? Is the graph going up towards positive infinity, or is the graph going down towards negative infinity? All right, same thing here. We have an equation. We want to know what is the graph doing. This is a positive function, and it's an even degree. So even degree functions are going to look one of two ways. They're going to be going up if they're positive. They're going to be going down if they're negative. Well, this one's positive, and it's even, so it's going to be going up. So we're going to draw this a little bit bigger. So as we go to the left on the graph, what is the graph doing? So as x approaches negative infinity, f of x is going up towards positive infinity. All right. As we move to the right on the graph, as x approaches positive infinity, what is f of x doing? The graph is again going up towards positive infinity. And that's it. That is the end behavior of your graph, if you're given functions instead of the graphs itself. If you're given functions, I would highly recommend you draw a quick sketch of a graph. You only have 4 options to pick from. I put those 4 up at the top there. All right, just figure out which one it is that you need based on what your function is doing. Next, we go to the graphs themselves. So this graph is going up here and going down there. So we already have the graph. We just have to decipher what's going on. So again, the same thing that happens. As the graph goes to the left, as x is approaching negative infinity, what is the graph doing? The graph is going down. F of x is approaching negative infinity. All right. As the graph goes to the right, as x approaches positive infinity, what is f of x doing? It is going up towards positive infinity. That is it. Okay. One thing I mentioned in my notes when we did this for class is that all of this stuff is always going to be the same. The only thing that's going to be different is which direction is the graph going. Is it going up or down? All right, we've got one more graph here. All right, those are the arrows. So as x approaches negative infinity because it's going to the left, what is our graph doing? Our graph is going down towards negative infinity. As our graph moves to the right, what is our graph doing? Oops, that's ugly. Our graph is again going down toward negative infinity. That is it. That is all there is to do with end behavior. And again, you'll notice the first part of each one of these things is always the same except which direction the graph is going. Same thing for the 2 with the equations. Everything's the same except at the very end where what is f of x approaching, positive or negative infinity. All right. Next we're going to transformations. Number 2 here, what are these transformations? There are 3 things going on here. They are 1, 2, and 3. Okay, the first one, you have vertical stretch by 5. Okay, if it was a fraction there, it'd be a vertical compression. If it was on the inside of the parentheses next to the x being multiplied, it would be a horizontal stretch or compression. Okay. All right, number 2. Because it's inside the function, inside those parentheses, it's going to go left and right, and it's going to go opposite of the sign. So this is a minus. You'd think it'd go to the left by 3 because that's where the negatives are, but it's actually going to go to the right by 3. And then number 3, that 4, it's on the outside being added. It's a vertical transformation, so you're going to go up and down. You're going to follow the sign. Since it's a plus 4, you're going to go up by 4. That is good enough for me. Okay. All right. Describe the transformation. So here we go. So we have x to the third. We're transforming it by doing different things to it. So in the first one, we have a 6 on the outside, just like in the previous problem. This is a vertical stretch. By 6. All right. On the inside of the function being added or subtracted, it is a horizontal transformation. So it's going to either shift left or right. Because it's negative, we're going to go to the right. So I'm going to go to the right by 5. All right. The next one, negative 4 on the outside, is going to go down by 4. And the last one, this is the exact opposite of the first part, the g of x that we have. This is inside the function on the x being multiplied, so it is a horizontal compression by a factor of 2. Okay, let's check out some more. We have something on the inside being added. This time it's going to go to the left by 7. All right. The plus 1 is going to make it go up by 1. All right. There's a negative sign on the outside. It is a reflection over the x-axis. Okay. And if it's a minus sign that's being multiplied on the inside of the function that's on the x, it is going to be a reflection, but this time over the y-axis. Okay. All right. Next, number 4. We're going to do the same transformations here. We're going to see what happens if we do adding 5. Okay, so we're adding 5 on the inside of the function. Excuse me. All right, so what's that going to do? It's going to move our x values to the left by 5. So all the x parts of our point, the negative 2, the negative 1, the 0, the 1, and the 2, are all going to go to the left by 5 because it's plus 5, you're moving to the left. So if we subtract 5 from each one of these, I know it says plus, but when you're going to the left on a number line, you're going negative. So we're going to subtract 5 from each of those x values. You're going to get negative 7, comma negative 8, negative 6, comma negative 1, negative 5, comma 0, negative 4, comma 0, comma 1, and negative 3, comma 8. Okay, these are all points on your coordinate plane. So all the x terms of your point have been changed by subtracting 5. So what we're going to do is we're going to move all these points that are in our graph now 5 to the left. So 1, 2, 3, 4, 5. There's 1 point. Let's go again. There's again, here, here, and 1, 2, 3, 4, 5 right there. So all these points have moved 5 to the left. So you basically picked up the graph, picked it up, moved it over 5 spots, and then put it back down. Okay. See another example? Now in this case, there's two changes. There's the one on the inside and then the one on the outside. So the one on the inside, we're going to the right by 1. So all the x values are going to be adding 1. And we're going to go down by 2 for the subtracting 2 on there. We're going to go down by 2, so all the y values of your points will be subtracted by 2. So we're going to add 1 on the x and subtract 2 on the y. So we're adding 1 on the x. We're going to get -1, and we're subtracting 2. It gives you -10. All right, we're adding 1, it gives you 0, and subtracting 2 gives you -3. Adding 1 and subtracting 2. Adding 1 and subtracting 2, which gives you -1, there we go. And then we're adding 1 and subtracting 2. Okay, so how this works, you can use those points and plot, or you can just take the points that you have on the graph and then move them to the right by 1 and down by 2. So right 1 and down 2 puts the first point there. Right 1 and down 2, right 1 and down 2, right 1 and down 2, right 1 and down 2. So again, our graph has been picked up and moved to the right 1 and down by 2 each time. And there's the new graph for the new function. All right, next we're looking at extrema. I've got to sketch the polynomial and then describe how many extrema there could be, possibly. Okay, so an 8th degree polynomial, what that means is there's 8 possible chances for that graph to go through the x-axis. All right, so since it's an 8th degree, it's going to be an even function. So we're going to start up here. 1, 2, 3, 4, 5, 6, 7, 8. Notice they're both going the same direction, which is a characteristic of an even degree polynomial. Now, if we're talking about extrema, how many extrema could you possibly have for this? You're going to list all of them that are possibles. Okay, so how to figure this out, if you're just given the number of the degree, is you subtract 1 from the degree, so we get 8 minus 1 is 7, and pick every other number as an odd number till you get to 0. So we got 7, 5, 3, 1. You can't go less than 0, so we stop at 1. So that's the number of extrema you might have. We can count them out that we have. So we got 1, 2, 3, 4, 5, 6, 7. So we have 7 there. We could have drawn this 8th degree polynomial with less extrema. We just made it do the most it could possibly have. Okay. 3rd degree polynomial is going to go through the x-axis 3 possible times. It's going to start out down low here because it's an odd degree function. So it's going to look like this. 1, 2, 3. Okay, so again, we do the same rule that we had for the 8th degree. We're going to take 1, subtract from the 3rd degree, which gives us 2, and every other number. So the only other number you have is 0. You can have a 0, you just can't go less than 0. You can't have less than 0 extrema, sorry. Okay, 12th degree polynomial. Now we're going to get a little bit crazy with our graph. Again, it's an even. It's going to go through possibly at the most 12 times. We're going to do all 12. So we're going to start up here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. That is a 12th degree polynomial. And the number of extrema, again, you subtract 1 from the degree. So we're going to get 11. And then all the odd numbers towards 0. 9, 7, 5, 3, 1. So that's the number of extrema you could have for a 12th degree polynomial. And lastly, 9th, I'm going to start down low because that's where odd degree polynomials begin, unless they're negative. So I'm just going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now notice odd degrees start and end in different directions. Even degrees start and end in the same direction. Okay. To find the extrema, we're going to again subtract 1 from the 9th degree, which gives us 8, and then every other number. 6, 4, 2, 0. And that is it. That's how you find the number of extrema, and that's how you graph that little sketch of a graph. All right. Next, we're given 3 different functions. We want to multiply them all together and put them in standard form. Okay. So because we're doing this, we're going to rewrite them all out. It's going to be d of x. So we have d of x is equal to, let's make this bigger, 2x plus 1, negative 5x minus 3, and x minus 10. Now, generally, you could leave it like this, but our question does say put it in standard form. Because it says this, let's highlight it now too, in standard form, because it says that you have to actually multiply these things out. Okay, we can do the box method, you could do the rainbow method. I don't really care which one you pick. They both work. Okay, just for the sake of argument, let's use the box method here. So we're going to have 2x plus 1 and negative 5x minus 3. Let's make that real big. So we multiply the things that intersect on the boxes. 2x times negative 5x is negative 10x squared. Negative 5x times 1 is going to be negative 5x. 2x times negative 3 is negative 6x. And negative 3 times 1 is negative 3. Again, the corner boxes, or the diagonal boxes, are the ones that are the like terms. Those are the ones we're going to combine. We're left with negative 10x squared minus 11x minus 3. Now we still have to multiply that with the last term, which is x minus 10. Okay, let's make that big too. Okay, so we multiply again the intersecting boxes. Negative 10x squared times x is negative 10x to the third. X times negative 11x is negative 11x squared. X times negative 3 is negative 3x. Negative 10x squared times negative 10 is going to be positive 100x squared. Negative 10 times negative 11 is going to be positive 110x. And negative 10 times negative 3 is going to be positive 30. Okay, again, the diagonal boxes are going to be the ones that have the like terms. We can combine those together. So we will get negative 10x cubed. 100 minus 11 is positive 89 x squared. 110 minus 3 is going to be 107. And then plus 30. All right, for the last part, we have to, since this is a function, we have to put the d of x in front of it. And this is your answer. Okay, it shouldn't be hard, it's just time-consuming is really what it is. Laborious, that's a good word for it. All right, let's try the next one. Okay, we're going to do the same thing. We're going to, again, write it in standard form, so it means we have to multiply it out. We have c of x is equal to 4x plus 3 and 3x squared minus 6x plus 2. Okay, we can again do the box method. I think it's just easier for a lot of students because it organizes your information as long as you write it down correctly. We're going to do 4x and 3. We're going to do 3x squared minus 6x plus 2. Okay. All right, so we multiply things out. We have 12x to the third. We have negative 6 times positive 4 is negative 24x squared. I almost forget the squared. 4x times 2 is 8x. Okay. 3x squared times 3 is going to be 9x squared. Negative 6x times 3 is going to be negative 18x. 3 times 2 is going to be 6. Again, we're looking at the diagonals to combine our like terms. So we have 12x to the third. Let's do this. 24 minus 9 is going to be, that's not right. 24 minus 9 is negative 15 x squared, and then negative 10x plus 6. And this is all c of x. Make sure you put your function notation part in there to finish off the problem. And that is the answer. Okay? All right. Next, we're going to compare two different things in the same problem. All right, we have a function and we have a graph. All right, we want to know what is the greater number possible extrema. So we want to know extrema for this. Which one has the more extrema? Okay, so a quintic function is going to be x to the fifth. Okay, all right. A is less than 0, which means it's going to be a negative function, and it has 5 distinct real roots, which means this goes through the x-axis 5 times. Okay, so if we remember back to the extrema when we were drawing those sketches of the graphs, this is x to the fifth, so it's an odd function. It's negative, so it's going to start up here. It's going to go through the x-axis 5 times. 1, 2, 3, 4, 5. So that's what your graph should look something like. If we're talking about extrema, we're looking at the peaks and valleys of our graph. So we have a valley, peak, valley, peak. There are 4 extrema. Okay, so now I got to check out the other graph. This has a valley and a peak. It has 2 extrema. This is also a odd degree graph. This is a third degree graph. All right, as far as we know, looks like a third degree function, or it could be. All right, but since we don't care about that, we care about the number of extrema. This has 4 extrema, so this has the greater number of extrema, and that's what we do. This is showing your work. So it says, say, show your work, make sure you show your work. That is just circling the extrema is good enough. You're identifying what you're looking at. All right. Next, which has a greater relative maximum? So we want to know out of the graphs that we have, which one has a bigger, higher term, okay? So the graph here we have, the highest point of the graph is right there. It is at -1 for the y value. That's the highest number it has, -1. We're looking at the y-axis. Now we want to look over here. Based on this information, a quartic function is x to the 4th. All right, a is greater than 0, which means it's going to be a positive function, and 4 distinct real roots, which means it's going to go through the x-axis 4 times. Okay, so I'm going to change back to blue. Our graph's going to look like this. Since it is x to the 4th, all right, we're going to start up here. We're going to go down through the x-axis 4 times. 1, 2, 3, 4. Now, because it went through the x-axis, you can see that we had to have an extrema right here. Okay, now, I don't know what that number is, but what I do know is that it's above the x-axis. Here is the x-axis. Since it is above the x-axis and our other graph is below the x-axis, this one must have a greater relative maximum, okay, because it is above the x-axis. So it's a positive number. All right, moving on. Okay, so we have this quartic regression line. Don't worry too much about the terms. That's just this line. This is the line that kind of fits the data that was found. Okay, we're going to answer some questions about it. Okay, so according to quartic regression, during what day or days was the stock price the highest, and approximately what was the price? Well, the highest part was here. Let's change that color. Highest price was here, so that would be day 30, this is 32, this is 34, 36, 38. So about day 38, and the price is about $9. So which one best reaches that conclusion? Part C, day 39, about $9. Okay, that's the one that best fits the information that we have. Okay. All right. Part B, during what day or days was the stock price predicted by the quartic function unreasonable? All right, so unreasonable. When is the stock price going to be unreasonable? It is unreasonable when it is less than 0. Oops. Okay, if it is less than 0 and it's negative, that's an unreasonable stock price. Stock prices don't go negative. Okay, so we're looking at the days for this. So this would be about day 17 through day 23. Okay, so look, G, day 17 to 23. All right, that's when the stock price would be unreasonable because it is negative. That doesn't make any sense. Now, the model goes negative, but in reality, you can't have a negative stock price. Notice there's no dots underneath the x-axis there where it would be negative. Okay, the dots are the actual data. The line is what's the model for the data. Part C, according to the quartic regression, which is the line, during which days was the stock price increasing? There's a bunch of different days, okay? So we start off at day 0. Oops, keep forgetting to put the pen. Starting off at day 0, going to about day 4. So 0 to 4, it is increasing. After day 4, we go down until we get to, let's say day 20. And we're starting to increase here up until we get to day about 39. Okay, that's when it's going to be increasing. Those two spans. Okay, so let's see which one works the best out of the things that we're getting, or the choices that we have. So the best one we can see, now it says day 23. I can see where they're saying that because, sorry about that, moving all around. Day 23 is here where the stock price is going at 0, all right, and going up. So although I said day 20, day 23 makes a lot of sense because day 20 is where it's negative. Since it can't be negative, it makes sense where it's going to be 0 and then going back up. So I would say K would be the best answer for that. Okay, makes the most sense. All right, notice it doesn't say 0 to 4, but that's fine. All right, some of the other places it's always decreasing. Okay, so next, using the quartic regression to determine the average rate of change over the interval 38 to 44. So these are both x terms. This is x1 and x2. This is the range that we're looking at on the x-axis. So let's look at our graph. Let me erase some of this stuff. So it says 38 to 44. So 38 is going to be right here. Okay. And it wants us to use, notice it says something in the problem here. It says using the quartic regression, which means we want to use the graph and not the dots. Okay, up to 44. So 44 is right here, right there. So we're looking for y values. So we have 38. This y value is going to be 9. So we have 38, comma 9 for 1 point. And we have 44, comma, what is that going to be? 5 for the other point. So these are the 2 points you're going to use in your average rate of change problem. Okay, so we have 38, let's write it over here. We have 38, comma 9, and 44, comma 5. Now you're going to use the slope formula, y2 minus y1 over x2 minus x1, to find the slope between those 2 points. Okay, so y2, we're going to say that's 5 minus 9 over 44 minus 38. So we have negative 4 over, what is that? 44, I should know that in my head, it's 6. Okay, so we have negative 4 over 6. We're going to reduce this. We're actually going to divide it in total. So it's going to be negative 4 divided by 6. It's going to be negative 0.667. There we go. All right. So what that means, and that's what part E is, okay, is that between those 2 days, day 38 and day 44, between those 2 days, the stock price is decreasing because it's negative, it's decreasing, and you can see on the graph it's going down. So the stock price is decreasing by $0.667 per day. So we are explaining what's happening, what that number means in terms of our scenario that we're dealing with. So that's talking about the stock price over a certain number of days. So the stock price is decreasing because it's negative by $0.667 per day. That's it. Okay. All right, next, we have to use the graphing calculator. So I have, since you have the notes hopefully open, or the review sheet hopefully open, I'm going to switch to my calculator function. And I'll open up this on my computer. All right, so we're going to see what this function is going to do. I'm going to find the relative minimum and maximum based on this equation, all right, in our graphing calculators. Now you can do this on your own iPad because you have Calculate 84 app on your iPad, or you should have it. If you don't, please go to the App Service Center and download Calculate 84. It should be free. It's already given to you guys. I'm just going to download it if you haven't done it already. Okay, so let me change this out. Oh, I'm sorry, there it is. So we're going to go to y equals. We're going to clear out this other equation. You're going to put in the equation that you're given. So it looks like this. You're going to have x minus 4, quantity squared, and then x minus 5, and then x plus 1. Okay, we're going to graph that. It's going to be there. Okay, so now it says over the interval of -1 to +3. We want to find the relative minimum. So we're going to hit second. We're going to hit trace in the top row, and it gives us a menu of items. We want to pick 3 for the minimum. Okay, so now it says left bound. Now you can see on the bottom left-hand corner of your graphing screen, it gives you the x values. We want to start at -1. So we want to have the x value be as close to -1 as we can. I want to put it as -0.97. That's as close as I get to -1. That's going to be just enough. Okay, so I'm going to hit enter because that's the left bound. To the right bound, we're going to go towards +3. So I'm going to again watch the x terms on my bottom left-hand corner of my screen to get as close to +3 as possible. That's 3.069. That's good enough. We're going to enter again. And it wants us, well, then it has it for us right there. So on the bottom corner, it says the point is at 0.32 and -83. Okay, so it says -83.66. We'll do that, -83.66. So that is the relative minimum. I know you can't see it on the graph, but take your word for it. Down below on where the screen is, it's going to go down about 83 spots on the y-axis. So if we go back to our review sheet here, okay, the graph is, oops, you know what? Let's go back to the graph real quick. The graph's going to look a little bit like this, so let's kind of take a guess at what it looks like. It looks a little bit like this. Oops, lost the pen. Something along those lines. Okay, and our relative minimum is going to be that y value we found, which is -83.66. All right. Next, we have the next problem here. We're going to go back to the calculator. All right, so we're going to go to the y equals button. All right. We are going to put the values, we're going to go back to the y equals, clear it out, put the new value in there. All right, we have parentheses x minus 5, parentheses x plus 8, and then parentheses x plus 2. Okay, so we're going to graph that. It's really big. Let's do some zooming. Let's do zooming out. All right, so we're going to do this time it's going to be the relative maximum over the span, the interval of -10 and -1. So we're going to go do the same thing, get second, trace. This time we're going to hit 4 for maximum. We're going to look at the x terms. We want to go left towards -10. As you can see, as we're going over, we're at -5, -6, -7, -8. Let's go back to -9.9. So that's -10, pretty close. We're going to enter. We're going to go towards -1. So looking again at the x term on the bottom as it goes, the bottom left-hand corner as it goes towards -1. We're going to do the closest to -1 we can, so -1.1. It's about as good as we're going to get it. Hit enter again. And there we have it. Our relative maximum is 91.94. Okay, the graph kind of looks weird, but we can kind of take a guess at what it looks like. There we go. Pen. It's going to look something like this. Oops. Pen. Okay, and our relative maximum is 91.94. That's it. That's all you got to do. So you can use that as a guide to use your calculator. All right, we're going to do some more of these. Oh, sorry. Which one is a greater relative maximum? No, we don't actually have to figure out which one's greater. We just have to answer the question. All right, good. All right, this one is the same as the comparing as before. This time we're doing some average rate of changes. Change this to blue. All right, so average rate of change, we got from -3 to +1. These are, again, both x terms. Okay, so x1 and x2. It doesn't look very clear, so I'll change those again. All right, those are x1 and x2. Okay, so we look at those values here. We're looking at this point, -3 and -1, right? No, +1, sorry. I had the wrong one. This one. So those two that have parentheses around them are the points we're going to use to find the rate of change. Okay, it's again using that slope formula how we used before. So we have y1, or y2, sorry, y2 minus y1 over x2 minus x1. So we're going to have -8 divided by +4, which gives us -2. So that is the slope for that rate of change. All right, for the next one, though, we have a little bit of a problem. We're not given points, we're given a function. But what we can do is we can put these x values into our equation. So we're going to write them in and then solve for the y values and then use those points to do our average rate of change. So we have -3 to the 4th minus -3 plus 1. You'll notice I put the values in parentheses when I put it into the function. Please make sure you do that. It is really important for doing these problems correctly, especially because you should be using a calculator to do them. So I have 0.4 times -3 to the 4th power minus -3 plus 1. So make sure I put that in correctly. I'm going to get 34. Okay. Do the same thing when I do it with 1. So I have 0.4, and then I'm going to have 1 to the 4th minus 1 plus 1. Okay, I'm going to put this in the calculator again. I have 0.4, 1 to the 4th. Oops. There you go. Minus 1 plus 1. I'm going to get 0.4. Okay, so what that means is, here's my points. I have -3, 34, and I have 1, 0.4. I can then use these values to do our slope, our rate of change. So I got y2, which is 0.4, minus y1, which is 34, and then 1 minus -3, which gives us 0.4 minus 34 is -33.6 divided by 4. That gives us -8.4. Okay? So we're looking at the two rate of changes. We want to know which one is steeper. We don't care about the size of the number. We want to know which one's steeper. Okay, so -8.4 over 1 is going to be a steeper slope than -2 over 1. So that is going to be our greater average rate of change. Okay, same idea for this one. We're still doing average rate of change. Now our x values are going to be -3 and -1. Okay, so again, like we did before, we're going to put those values into our equation. So we're going to have 1/2 negative 3 cubed minus negative 3 squared plus 5 times negative 3 minus 6. Again, it's very important that you put those negative 3's in parentheses and do that in your calculator. I would again make sure you're doing this problems in your calculators if you didn't do so already. So I have 1/2 times negative 3 to the third. I have minus negative 3 squared plus 5 times negative 3 minus 6. All right, so put them all in there. I'm going to get negative 43.5. Okay, so I'm going to have my first point as negative 3 comma negative 43.5. I'm going to do the same thing, but this time I'm putting, what is the number? It is negative 1. So 1/2 negative 1 cubed minus negative 1 squared plus 5 times negative 1 minus 6. So 0.5 negative 1 cubed minus negative 1 squared plus 5 times negative 1 minus 6, which gives you negative 12.5. So our other point is negative 1 comma negative 12.5. So now that we have our 2 points, here's the 2 points. We're going to use the slope formula to find the rate of change. So y2 is negative 12.5 minus y1, which is negative 43.5, divided by x2, which is negative 1, minus negative 3. So negative 12.5, so it's going to be plus 43.5, gives us 31. And 1 minus negative 3 is going to be positive 2. 31 divided by 2 is 15.5. So that is the average rate of change for the first problem. All right, and now here we're given a graph. So to find the graph, again, we got to find the points. So negative 3 is the first one. If we zoom in here, negative 3 is going to be right there. So negative 3 comma 0 is the first point. And negative 1 is going to be over here on the x-axis. It's going to be, this point right here, which is going to be, looks like 12. So negative 1 comma 12. So these are our 2 points. Again, we're going to use a slope formula. So we're going to go 12 minus 0. Negative 1 minus negative 3. Which gives you 12 over 2, which is 6. Okay? And 6 is not as steep as 15.5. So this would be your answer. Again, this isn't necessarily hard, it's just long and it's a process. Okay, a lot of this is just calculator stuff. Okay, so don't give up and it's like, oh, it's too much work. It's really just writing some stuff down, putting in the calculator and figuring out what the answer is. All right, and that looks like it is it. Okay, please, if you need some help, come to a Zoom. You can even come to Zoom on Friday and ask some questions before you take the test. It is very important that you take the test by Friday. We have to start calculating the grades for the final week to let you guys know what your grade is before we get into master exams. All right, good luck.